So, good morning, everyone. Kunal here again with yet another video. And for today, we've chosen a very simple program to see if a given input or a given number is a palindrome or not. And we'll, as usual, be using Raptor to see how the flowchart for finding a palindrome looks like. Now, for those of you who would be wondering what a palindrome basically is a number which, when reversed, is equal to the original number. For example, 1 to 1 is a palindrome because the reverse of uh, the reverse of 1 to 1 is again 1 to 1. So 1 to 1 will be a palindrome. So in this video, we will take an input from the user and we will write a program, or rather we'll draw a program, a flowchart that will check whether the number is a palindrome or not. Now the reason uh, we are doing this on Raptor is because for those of you who are new to programming will start to appreciate how exactly these things work. uh, in a week or two, I will begin my usual series on uh, Java, and I intend to walk all of you through core Java, uh, the features that uh, are included in Java 8 onwards, with a lot of hands-on on data structures and dynamic programming. So that is the intent of beginning this series. But for now, let's just focus on the problem at hand, and let's start with getting an input box here. I want the user to input a number, so I'll say input a number to check if it is a palindrome or not. And let us save it in a variable called n. So this is the beginning. So we have a number now given by the user, and I want to check whether this number is a palindrome or not. Now, to check the number to be a palindrome or not, I will have to first reverse the number, and after reversing, I will have to compare the original number with the reversed number, and if they are equal, then I will output that the given number is a palindrome. So the process will be, I will take a number, I will reverse that number, and then I will check if the number is equal to the reverse. So there is going to be a reversal of the number, which basically is a loop, and then we will use a if else branching statement to check whether the number and its reverse are equal or not. So let's begin by reversing a number. And before I reverse the number, I will want to store this original number in some variable so that when I reverse n, I still have access to the original number. So let me take a variable. Let me call it uh, input. And I will store my n in this input. So this is a simple assignment. Whatever was the input value, I first stored it in n and then I assigned it to a variable called input. Very good. Now I can do whatever operation I want on my n. So I'll start a loop here, and the way I want this loop to run is I want to basically uh, take the original number and do a modulus operation with denominator 10 on that original number. So if, let's say, the original number is 345 and I do a modulo 10, it will give me the last digit of this number, and that is 5. Remember, the modulus is returning the remainder after the division is performed. So 345 divided by 10 is 34.5. The remainder has to be 5, which gets returned. So I will be performing this operation to get the last digit, and then I will do something like a floor of T45 divided by 10. The floor returns the uh, integer value after an operation is performed. So 345 divided by 10 is 34.5 and its integer value is 34. So we will be doing both these operations simultaneously within the loop. And the way I will do it is that I will run this loop for as long as my original number is 0. As soon as this number n, input number, becomes 0, the loop exits and the program, at least the iteration, stops. Until then, the first thing I will do is I will do the modulus operation. So here I will take a variable, say remainder, let's call it r, and I will do the n modulo 10 operation, and I will save this. So this is my first step. Now, of course, when I keep doing these operations, I am getting the last digit of n as an output here in this operation, and I'm storing it in r, but I want to uh, define one variable here which will hold the final reverse value. So let me call it revers, reverse. So I am taking one more variable which will store the final result after the entire reverse operation is done, and I will set it to 0. So to begin with, reverse is 0, and now I can go ahead and you know use this reverse to keep storing the numbers that I get as remainders when I perform this operation here. And the way I do that is I will do this. I will set my reverse to reverse multiplied by 10 plus r. This is a critical operation. So what I am doing basically is, so I am doing reverse multiplied by 10. So whatever was the value of reverse, I multiply it by 10, and then I add the next remainder to it. Will shift the position of digits in reverse by one towards the left, which basically means that the unit will become a 10, the 10 will become a 100, the 100 will become a 1000, and so on. So if I have 54 as, let's say, the value of reverse, and I have, let's say, 6 as the value of R, then when I do 54 multiplied by 10 and I add R to it, I will be getting a result of 540 plus 6, which basically is nothing but 546. So this is how and why I will perform this operation. And I'm done. I just need to add one more step to it, and which is to, so after the first operation, I will want to reduce the original number by truncating its last digit, by removing the last digit from the number. And the way I will do that is that I will set the value of n again to floor of n by 10. And I'm done. So here now we have the complete operation for reversing a number. And remember, I had stored my original number in a variable called input. So the last step, once the reverse operation is done, is to check if the number is a palindrome or not. And to do that, I will simply say if my input is equal to the reverse. If it is yes, then I will output it as the given number is a palindrome. Pretty simple, right? Or I will simply say it is not a palindrome. Is not a palindrome. Cool. And this is how this program runs. Let's test it. So let me take a palindrome first. 121. Let me run this. And the output is the given number is a palindrome. Cool. Let's take a number which is not a palindrome. Let's take 123. The given number is not a palindrome. So the program works. I hope you like the video. A lot more is coming. So stay tuned. And if you have not already, do subscribe to my channel.